manager. The example here shows through all 6 join types with concrete syntax. So here we use the table name two tables such as employees and department. We use the inner join as created keyword, and such wise we replace the keyword using left join, right join, full outer join depending upon the question. Here, the self-join aliases the same table twice, once as the employee and once as the manager, allowing us to traverse parent-child relationship within a single table. We now move on to SQL views, one of the most underutilized yet powerful features of relational database. A view is a virtual table defined by a select query. It stores the query definition, not the data itself. When queried, it executes the underlying select and returns the select dynamically. So views offer four major benefits: simplicity, security, reusability, and data independence. Here we created view using the syntax as create view, view name. Here the view name is emp underscore department underscore view. Next we gave the required SQL query. Next we displayed the view using select star from the view name we created. Next we use the create or replace view, which allows updating a view's definition without dropping and recreating it. Next we dropped a view using drop view, view name. It basically deletes the view which we have created. This section addresses a critical security topic, SQL injection, which consistently ranks among the top web applications. SQL injection occurs when malicious SQL code is embedded into the user input, which is then executed by the database without proper validation. The vulnerable example on the screen shows a query constructed by string concatenation. An attacker inputs 1 equal to 1 effectively bypasses authentication entirely. The condition always evaluates true, returning all records. The safe alternative is a parameterized query or prepared statement. Here the user input is bound as data, not code. The database engine treats it as a literal value and never executes as a SQL. The additional prevention techniques include input validation, whitelisting, stored procedure, applying the principle of least privilege to database account, web publication firewalls, and input escaping as a last resort. The main key takeaway here is never concatenate user input directly into a SQL query. Always use parameterized query. We now arrive at one of the most powerful features in modern SQL, window function, which enable advanced analytics without losing row level detail. A window function performs a calculation across a set of rows related to the current row. But critically, unlike group by, it does not collapse those rows. Every original row is preserved in the output with the output and the additional column. The syntax revolves around the over of clause, which defines the window. Partition by divides the rows into group. Order by determines the sequence within each group, and rows or range defines the frame. So the window function falls into mainly three categories: aggregation function, ranking function, and value functions. The aggregate window function compute rolling or partition scoped totals while keeping all rows intact. The example here shows for each employee a running cumulative salary, total ordered by the hire date, the department average, department head count, and each employee's deviation from the department average, all in a single query. The critical distinction highlighted here is group by collapses rows into one per group, partition by divides rows into groups for calculation but retains every row in the output. This makes the window function indispensable for analytical reporting. Ranking function assigns positional values to rows within a partition. The differences are subtle but important. Row underscore number assigns a unique sequential integer. No ties, always distinct. Rank gives tied rows the same rank but then skips the next rank. For example, after 2 rows ranked 1, the next rank is 3. Dense underscore rank also gives the same rank but does not skip. So after 2 rows ranked 1, the next rank is 2. N-tile distributes rows into n equal buckets, useful for percentile analysis. Percent underscore rank and cum underscore dis provide relative position as a decimal fraction. The query here demonstrates all 4 ranking functions side by side, making the differences immediately visible. Value function allows us to access data from other rows relative to the current row without a self-join. For example, lag of retrieves the value from n rows before the current row, ideal for a period over period comparison. Lead retrieves the value from n rows after, useful for forecasting or next period analysis. First underscore value and last underscore value return the first or last value in the window frame. Nth value returns the nth row's value within the frame. The example here computes a month over month salary change. The next highest salary, the department maximum, and the second highest salary, all in this one compact query. This kind of analysis would traditionally require multiple joins or subquery. So in the final section, we bring everything together, writing complex multi-relation queries that combine multiple SQL features simultaneously. The first query on screen is a comprehensive example. It identifies department where the average salary exceeds the overall company average using a subquery with having, then uses a join to enrich the result with department names, and finally applies rank and average as window functions to show each employee standing within their data all in a single query. The second example solves the classic top n per group problem, finding the top 3 earners per department. This is achieved by wrapping a row underscore number window function inside a derived subquery, then filtering on the row number externally. This pattern is widely used in real-world data engineering and reporting. So this is the quick summary reference for all the topics we have gone through. Each of these features used together define what it means to work with SQL at an intermediate to advanced level. Thank you.